Hi everyone, welcome back. Let's see one of the question on the concept of semaphores. Does the code guarantees the mutual exclusion or not? So guys, here if you look into here, the value of s will be 1 and the value of t will be 1, and they have given the question there as the mutexes. Mutexes means they are going to be a kind of binary semaphore whose value will be either 1 or 0. Now, does it guarantee the mutual exclusion or not? They are asking. Now, suppose for example, I can say it as P1 and I can say it as P2, right? Mutual exclusion means what? At the same time, only one process has to be allowed inside the critical section. Now, suppose for example, let me queue this as numbering 1, 2, 3, 4, and this will be 1, 2, 3, and 4. So for example, process P1 got the chance and will execute the first line. What will happen? P of s. P of s means what? Down on s 0. Done first line execution. Next second line, if it executes, down of t, yes, executed, and enter into the critical section. Now suppose for example, critical section is entered. So for example, it has preempted here. Can P2 will execute or not? It will perform P of t. If it performs P of t, what is the value of P of t? -1. Does -1 is less than 0? Yes. So that's why it will end for blocked state. Guys, to make it clear, just go with the previous videos of the concept of semaphore so that you can get the clear idea. Right? When it is -1, it won't allow. Right? So as the first line itself is not executing, it won't allow for further process. Which means that here you can able to observe only one process entered the critical section, and does the other process allow? No. This is one way, right? You have to analyze it in many different ways, not only the single way. Okay, fine. For example, if it comes out like v of t done and v of s done. V of t means what? Up of t 1, up of s will be 1. Means it has done with line number 3 and 4. Now, can P2 is allowed? Yes, might be allowed based on the chance. For example, if P2 got the dot 1 and 2 executed, you are going to get 0 and 0. Then if it is preempted, can the P1 is allowed? No, it will be entered for the blocked state, which means that at any point of time, only one process is going to be executed in the critical section. So I can say that mutual exclusion is guaranteed. Okay, this is the given question, so our answer will be yes, guaranteed. But I can extend the question something like that. Can it contains the deadlock? Right? The order what we have taken is a simple order where you are not observed any kind of deadlock, but mutual exclusion is guaranteed. But if you observe the situation where if the mutex values of s and t are 1 and 1, and P1 executing the line number 1 means P of s. P of s means what? Down of s. Assume here it is preempted and P2 got the chance to enter P of t and it will be decremented by 1, that is 0. So now preempted, which means that P1 execute one line, preempted, P2 execute one line and preempted. Now suppose for example, either P1 got the chance, had to execute the line number 2. When it is executing the line number 2, what will happen here? P of t. Down of t means what? Negative value, which is going to be always here. Waiting. Right? After some time, definitely it will go for outside of the CPU and give chance to again for P2. Now P2 also execute the second line, and P of s, which means again -1, which is not allowed, so again it is going to be in waiting state. Right? Even though now you are going to give chance to P1 and P2 for how many number of times, definitely it is going to be in deadlock. Means I can complete you. I am saying that P1 is holding one resource and P2 is holding one resource, and to complete the P1, it is required a resource which is handled by P2, and to complete the resource P2, it requires one more thing, that is P1. So based on that, it is going to be in kind of looping, right? When you are going to observe some kind of a loop, I can say that deadlock is happening here, right? So how can we avoid here the deadlock? Can we go with something like here, instead of going with the P of t and P of s, can I go with once again P of s and P of t the same way what I have written here? Just analyze it and you can understood what is happening here, right? So in this particular step, it is going to overcome the deadlock. Okay guys, now the solution is, does you need always two down operations to perform mutual exclusion? No need. You can go with one down and the other also one down, right? No need of two consecutive down operations. Then also you can achieve the mutual exclusion, right? Hope you understood this video clearly. Thank you.